Okay, so this is question number 1. You're told to solve the following differential equation using the method of undetermined coefficients. So we want to use this method here. And then the approach we're going to use is the annihilator approach. So we're going to start by solving the first one. So we have about 4 questions here. So we're going to start with the first one. That is A. So let's scroll down to the first question, which is A. It says you're given the differential equation y prime prime plus 2y prime plus 2y equals 5e to the power 6x. So how then do you solve that? So we know that the general solution of this differential equation should be of the form y equals yc plus yp. This is how the general solution should look like, where yc is the complementary function and yp is the particular function. So we're going to go ahead to find yc. So the first thing is we want to find yc. Now to find yc, we're going to solve the homogeneous equation. Yeah, that's the associated homogeneous equation. So we want to solve y prime prime plus 2y prime plus 2y equals 0. Now to solve this, the first thing is we find the auxiliary equation. So whenever we find our y, replace with m squared plus 2m plus 2 equals 0. And then when we solve this, what we would get is we get complex roots as m equals minus 1 plus or minus I. And then based on the videos we have done past, we know that whenever we have complex numbers as the root of the auxiliary equation of a differential equation, the solution should be of the form yc equals, so this is my alpha, so this is going to be e to the power minus x into c1 cosine of x plus c2 sine plus c2 sine of x. So this is what we know for our yc. So the next thing is we want to find yp. Now how then do you find yp? Now using the annihilator approach, we need an operator that is going to set the right hand side to 0. So what operator is going to set this to 0? That's the thing we want to find. So based on the previous videos we've done so far, we know that d minus 6 annihilates 5e to the power 6x. So we know this. So since d minus 6 annihilates 5e to the power 6x, I'm going to apply this operator on the differential equation that we're given. That's this differential equation here. So we apply it to both sides of the dE. So we have d minus 6 into, so we have y prime prime, so we're going to write d squared minus 2d plus 2 into y. So that's another way of writing the differential equation equals, so we apply to this side to d minus 2 into 5e to the power 6x. So that's what we want to do. And then since we know that this d minus 2, this should be d minus 6, not d minus 2, that's d minus 6. So since we know that d minus 6 annihilates this, so what we have here goes to 0. So what we now have left is d minus 6 into d squared minus 2d plus 2 times y equals 0. So this is a homogeneous equation. Now to solve this, I need the auxiliary equation. So the auxiliary, wherever you find your d, replace with m. You have m minus 6 into m squared minus 2m plus 2 equals 0. And then when we solve this, we're going to have either m equals 6 or m equals minus 1 plus or minus I. And then based on what we have here, so we have the general solution of this to be y equals c1 e to the power 6x plus, so since we have minus 1 here, so it's going to be e to the power negative x into c2 sine of x plus c3 cosine of x. Now this is the general solution of this newly formed homogeneous equation. So the next thing you want to do is you want to recognize the complementary and then the particular, the assumed form for the particular solution. So since we have e to the power minus x here, which is a yc, and then we also have it here, so this will be my yc, then the remaining part is what we'll call our yp. So now I've already gotten a form for my yp, so I could rewrite my yp as so we could say let yp equals, so instead of writing c1, let me call it a new constant, say a e to the power 6x. So this is the assumed form for the particular solution. So since we are assuming that yp satisfies this differential equation, it implies that when I substitute it into here, here, and here, I must get 5e to the power 6x. So I need to find the derivative and the second derivative. So if yp is this, then yp prime would be 6a e to the power 6x, and then yp double prime will be 36a e to the power 6x. So when we substitute that into that, we're going to have 36. So we're substituting all these values here back into the differential equation. So the first one we have is 36a to the power 6x e to the power 6x plus 2 times 6a e to the power 6x, then plus 2 times a e to the power 6x equals 5e to the power 6x. Now that's exactly what we have here. So I've just replaced the respective values of this y derivative and the second derivative. I've replaced them with the newly found particular solution substitutes. So when we add all this up, what we're going to have is 50a e to the power 6x equals 5e to the power 6x. So and then we want to compare coefficients. So you observe the coefficient of e to the power 6x here is 50a, and the coefficient here is 5. So on comparing coefficients, so this implies that 50a equals 5. So if 50 equals 5, then a equals 5 over 50, which is 1 over 10. And then since we said our yp equals a to the power 6x, so therefore my yp equals, my a is 1 over 10 e to the power 6x. So this is my yp. So and then since I know my yc, since my yc is this and I have my yp, then the general solution of the differential equation, so therefore the general solution is y equals yc. So the yc I got was e to the power minus x into c1 cosine of x plus c2 sine of x, then plus our yp, which is 1 over 10 e to the power 6x. And this is the final solution of the differential equation that we're given.